Hey, I guess you knew it was coming. We're in algebra land with x's and stuff, and what are we going to be able to do? Well, we have to work with fractions in algebra land as well. So what this presentation is about is right there in the middle of the screen. What do fractions mean, and how do you add and subtract them? Because if we've got a pronumeral in the fraction, as is likely now, because we've got algebra, we've got pronumeral standing for missing numbers. Hey, we're going to have to be able to do some fraction work. So let's look around the screen and see if we can answer the question, what do they mean? Here are two fractions, 2/3 plus 5/4, 5/4. Okay, so 2/3 represents a fraction of a whole, 2 parts out of 3 if you like. 5/4 is bigger than 1. Well, 4/4 is 1, and you've got an extra quarter. Now you might think now, this is going to be hard to add them up, because this one is written as 2/3 and this is 5/4. They are different from each other, aren't they? They're different sizes. So you can't just add the 2 and the 5 of different things. It's like 2/3, 2 cats plus 5 dogs, 5/4. That's going to be our challenge. I wonder if you remember how to do that. This one up here is a bit better though, isn't it? It's 5/4 or 5/4 plus 3/4, which should be 5 dogs plus 3 dogs, 8/4. And that would maybe cancel. 2's into 4, 4's into 8 go 2, which is the answer comes to 2. Do you remember any of this stuff back in your junior maths? What about this one? This one is 3/4 plus 7/8, but it's pretty easy to change this to 8s, isn't it? You could multiply top and bottom by 2 and get 6/8 plus 7/8. That would solve our problem because you'd have the same units. So a lot about adding and subtracting is we want the same units or the same denominator, bottom line in the fraction. Do you remember that stuff? And what we're going to do is say, well, hey, can we make the transition to these where there are x's? Can you do that, do you think? Pause the presentation, discuss it with your classmates. Hey, you should be able to, shouldn't you? Because x just stands for a number. X is a pronumeral in algebra land that we've used to solve problems and to describe patterns. X is a pronumeral, stands for a number. So what we do up here in ordinary real number land, we should be able to do down here because x is just standing for a number, an unknown number. All right, let's go and investigate this. I think you'll get excited about this one. So come down now and let's just review what we do with fractions ordinarily. Okay, so this one is good, isn't it? 5/4 plus 3/4. We've got 5 of something plus 3 of something. We can just say that's a total of 8 of that, 8/4. And I did that above. So that's 2. Let's have a look at this one. This is both over 4. Let's add up how many we've got. We've got x/4 and 2x/4. So that's okay. That's 3x/4 or fourths. Okay, so that's the first type. That's a pretty friendly type. You can see what's going on there. Let's get rid of that. Let's come down now and have a look at the next one. The next one doesn't have the same denominator or common denominator. So this is 3/4 or fourths. This is 7/8. So we need to do something about this one so we can collect it up with the 8s. Let's make it into 8s. How would we do that? Multiply top and bottom of the fraction by 2. Because 2/2 is 1. So we're not changing the fraction, are we? But that gives us 6/8. Do you remember that? Plus 7/8. So 6/8 and 7/8. 6 dogs plus 7 dogs. 13 dogs, if you like. Just think about that. So over here in Xland, algebraic fractions, can we do the same thing? Well, x just stands for a number. So yes, we can. And we get 2x/8 plus x/8. And they are all 8s. So we've got 2x, lots of them, plus x. We've done this before. That's 3x, lots of something. 3x, lots of 8. Eighths. Okay, you get the idea. It's fairly commonsensical. Need to talk to your teacher about that. Maybe do some revision of the old fraction work because we're moving on from there to Xland, to algebra, with unknown numbers there. Okay, so come on, and let's have a look at the last one, which is, again, as we said before, these are thirds and these are quarters. So we can't actually combine them as they are. We've got to change them to something common that is in common, or the same. So the common means same here. So we want the same denominator. So what is the common denominator of 3 and 4? Well, we want the lowest one, really, and here it would be 12. What's a number that both of those go into? You can times them. That won't always give you the lowest one, though. We want the lowest one. So we want to multiply we want to find something in the bottom line which is common or the same. So 4 times 3 is 12. So let's multiply top and bottom of this one by 4. Okay, and that will make 12. So let's do that. That will be 4 times 2 is 8 over 4 times 3 is 12. So that's equivalent, because multiplying top and bottom of a fraction by the same number doesn't change it, because 4 over 4 is 1. We're not changing the meaning. Okay, so let's do it on this side. Just rub that off for the minute. Multiply top and bottom by 3. 3 times 5 is 15. 3 times 4 is 12. So we've got the lowest common denominator or bottom line there. So they are lots of the same thing. They're lots of twelfths. Okay, so 8 dogs, 8 twelfths, plus 15 twelfths is 23 twelfths. Okay, get the idea. You must have a common bottom line here so that you can add them up, so that they're the same unit and you can add them like we were doing with like terms. Well, what would it be in algebra land? Well, surely, because x is just standing for an unknown number, we will go for the same denominator. So this would be 4x on 12 plus 3x on 12. And because they're all twelfths, we can add them up. Common denominator, 4x plus 3x, 7x, lots of 12. That lots of a 12. Now, do you get the idea? What the big transition is here? Well, it's not a big transition. It's just you accepting that x stands for a number, and you can do with x's what we've been doing with numbers. And gee, we're building up a lot of stuff here, aren't we? We've chosen to work with x, and now we've got to be able to do all the mathematical operations that we do with ordinary numbers in Xland. Okay, come down now, and let's have a look at from Hayes and Harris publications here. And you should have that Year 9 Australian curriculum book handy by so you can work with it. Here we are. To add two fractions, we obtain the lowest common denominator and then add the resulting numerators, because they are the same unit. Same units, if you like. Same units if the denominator is the same. So this is A lots of 1/6, and this is B lots of 1/6. So you just add them up. What about subtracting? You remember how to do that? We do the same thing. As long as they are the same units here, A 1/6 minus B 1/6 is A take B, 1 over C. Okay, lowest common denominator. So we have done one just like this. This is 4 and 3 again, so it's 8 over 12, and this is 3 over 3, so it's 15 over 12 is 23 over 12. Our common denominator there was the lowest common denominator, LCD. You could use lowest common denominator. And we did the same thing here, just going over that one again. Okay, we're making a common denominator of twelfths there. And 4x plus 3x over 12. Okay, converting it to a common denominator, because then it's basically adding up the same units, twelfths. Are you ready? I think it's time for you to have a go. Let's have a look here at an example from Hayes and Harris. Rise a single fraction, rise a single fraction. Okay, look at this one. This is a special case because one of the denominators is the common one. So you can actually just change the other into sixths by multiplying top and bottom by 2. So you want to spot that at the beginning, that 3 can be multiplied up to 6. You don't have to use 18 or some bigger number. Okay, so leave this one unchanged and convert the other, 4a over 6. So we've got a sixths and 4a sixths. That is a plus 4a sixths, or 5a. Same maths, but just a little bit different to look at when you've got x up there. Let's have a look at this one. Different denominators, you want something in common. So you could multiply them together and say, well, it'll be sixths. So let's change the thirds to 6. Multiply top and bottom by 2. Let's change the 2's to 6. Multiply top and bottom by 3. Therefore, let's work it out. 2 by 2x, 4x. 2 by 3 is 6. X by 3, we put the 3 in front, remember? 3x. 2 by 3, 6. Now we've got common units. We've got 4x sixths. Take 3x sixths. We'll have 1x lots of a sixth. Okay, are you getting it? You might have to pause, talk to your teacher, and just check that out. Okay, let's come down now and have a look at another variation. Oh, this looks different. Why does it look different? Have a look in here. They aren't fractions, are they? So can we make them fractions by calling 3 over 1? That's okay, isn't it? And x over 7. Now we want to change the 1's to 7. So we multiply top and bottom by 7 is 21, and x over 7, and we can't join those up. These are not like terms. That's 21 plus x over 7. Just remembering your rules. Remember, the Huddyism maths learning is sequential and cumulative, and you must remember that we dealt with terms like this before, and we had to leave them because 21 is 21 units and x is an unknown number, so you can't join them up. Let's look at the 2. Call 2 over 1. Now we want to make this into thirds, so we multiply top and bottom by 3, so we get 6 over 3. And it's C take 6 over 3. But C thirds and take away 6 thirds. And you can't go further because this top line doesn't have any like terms. All right, do you think you're getting anywhere here? You might have to go back over these explanations and just check that you know what to do there. Let's come down and have a look at some for you. So here we are. The top line is the first type, and the bottom line you've got to go over 1. So n would be n over 1, wouldn't it? 7 over 1. You must be working with 2 fractions so that you can add or subtract them. Okay, so check that out. Now what I want you to do is to pause the presentation, have a go at maybe the first 2 and check the answers, and then move on. Keep checking your answers so you're not practicing the wrong thing. Don't get them all wrong and find that they're all wrong at the end. So pause it, have a go and toggle forward on the video and check your answer, then go back and do the next one. Let's see the set of answers now. Here they are. And that's the end of this presentation. I want you to look carefully at it because we're going to build on it. There are actually 3 presentations on algebraic fractions, so I think you should like it. But for the moment, it's cheers from me.